All right. Thank you to Patrick and the Lacob family for the opportunity to speak in front of you. I'm humbled by the prior speakers and future speakers to be up here today. So maybe just a little bit about me, because it might not be obvious why a brain stimulator company is at a sports business conference. I am a medical doctor by training. I went to Stanford for medical school and got a master's in neuroscience from Stanford as well. So the brain has been my whole life, from the time I was a kid to a bunch of school. And then professionally, I have built a career around building brain stimulators. So this idea of, like, what if we could use electricity as medicine? So this might sound crazy to you at first, but hopefully by the end of this talk, you might think what we do today, that is use drugs, is crazier than what we could do with electricity as medicine, and that electricity is a far better approach. So a couple of problems with drugs. One, you take it by mouth. It goes all over your bloodstream, hitting your liver, kidneys, lungs, heart, all the major organ systems unnecessarily. The small amount of drug that makes it through the special filter called the blood-brain barrier, when it gets to the other side, if it gets to the other side, it similarly goes all over the place. So there's a lot of friendly fire, unnecessary friendly fire that drugs produce, and you see that in the form of side effects, right? For many drugs, actually most drugs that primarily affect the brain, I will show you a list of side effects that are almost as bad as the disease it's trying to treat. So my last company, which was a pretty big effort, was called NeuroPace. So that's not the current company. This is my prior endeavor. And it's interesting to see how my life has crisscrossed with the Lacob family in very significant ways over the past. So Joe Lacob was actually the Series A investor of my last company when he was at Kleiner Perkins, towards the end of his legendary career as a healthcare investor. So we built this guy. So that's not actual size. It's much smaller. It's this big. And that gets implanted in the skull with electrodes going into the brain. What this does is it's constantly, once it's surgically implanted, it has everything to function autonomously. So it's got its own battery. It's got its own computer board, computer chip, and software. It has everything it needs to function autonomously for 5 years. What it's doing is it's constantly monitoring the brain's electrical activity, and if it detects an electrical signal suggestive of a seizure about to happen, it proactively delivers a small electrical impulse to the brain to normalize the brain's activity. So I'm proud to report that we got this device to the finish line. We had our big day in front of the FDA, where we got a 13-0 vote in favor of approval. So this device is out there in clinical practice, and it's helping thousands of people out there with epilepsy. I don't think I mentioned that. So this is a device for epilepsy, where drugs have failed these people for as long as drugs have existed. So many people with epilepsy would rather just have the disease than the side effects of the drug. So, this is an example of electricity coming in, using it as medicine, and doing a far better job than a drug could. Here's another example. All right, so this is a gentleman with Parkinson's disease, and you can see the characteristic tremor over on your left. This is the same gentleman literally seconds after you turn on the stimulator. So you could just see the symptoms melt away, literally before your very eyes. The problem with all of these technologies is that they're invasive. So I don't have this slide up there, but this is the problem. Nobody wants the surgery. And so my now co-founder and I, who's a longtime friend and colleague from our last company together, we thought, what if we could take these products that are all implanted, surgical implants, and build them into wearable products that do not require surgery. So, since this is a business conference, I thought I'd just bring this up. Neurostimulation is a $5 billion industry that nobody's ever heard of. The reason why it's a $5 billion industry and you haven't heard of this is because it doesn't take that many unit sales to get to $5 billion. So this is the business model. We sell implantable brain stimulators for $30,000 to $40,000 a pop. All right, so you do the math there. It doesn't take that many units sold to get to $1 million. In the case of NeuroPace, the average age of first implant is 28 years old. So they're young people. And the battery wears out in 3 to 5 years, which requires you to get another device. So have you guys studied churn and long-term LTV? I mean, the LTV of a patient, of one person when they're 28, is in the hundreds of thousands of dollars. And there's virtually zero churn. Like if you get your first device, there's almost 100% chance you're going to get a second device and a third device. So you roll this all up, it's a big industry. And my opinion is that this industry has gotten lazy, right? They like sitting on these near monopolistic franchises selling their products. So there's maybe 5 companies in the whole world that sells these kinds of products. And they do quite well. You know, what we want to do is ask the question, like, what can we do to get better, right? Like, can we get rid of the surgery? And if we can, could we change the world? Mark before me talked about Olin about, world-changing business opportunities, world-changing business research. Like, this is what we're trying to do. Okay, so the inspiration for the technology stack that Halo was built on came from the scientific literature. So my co-founder and I, we started reading papers over 10 years ago, scouring the research, looking for ways that scientists are looking for technologies that scientists are playing with to deliver neurostimulation non-invasively. So back in 2006, there were only 10 papers in the whole world published on this topic. And what we saw slowly over time is this hockey stick in growth in the number of publications, also the quality of the publications. So we went from 10 papers to 2,000 papers in the span of 10 years. And that's really impressive on a scientific timescale. Wasn't just universities getting results. So we saw folks that are really looking for a practical application using the technology and getting results. So the United States military were training drone pilots and snipers, and literally half the time if you paired it with this technology versus not. So this gave us some confidence that it not only works in a lab, but it could work in the field. All right, so we've been talking about this technology. What is it? So the technical word is transcranial direct current stimulation, or abbreviated TDCS. It involves placing electrodes on the scalp in a very specific part of the scalp. You could put the electrode over the part of the brain that you want to affect, right? Turn on the stimulator. That creates an electric field that is strong enough to get through the skull while gently interacting with the superficial layers of the cortex. Do that for 20 minutes. And what that does is that it induces a temporary state of what neuroscientists call hyperplasticity, but we can think of it as hyperlearning. Okay, and this temporary state of hyperlearning lasts for about an hour. So what we ask the athlete to do, since our first application is for sports, and we'll talk about that in a second, is what if we stimulated the part of the brain controls movement in our bodies? And then we fed the brain movement-based training repetitions. So shooting three-pointers if you're KD or Steph Curry. Practicing violin if you're a violinist. Practicing doing surgeries if you're a surgeon. Practicing shooting a gun if you're a special operator in the military. Like whatever that movement is, if you practice while you're in the state of hyperplasticity, you're going to learn it faster. So we got to a sports application through a lot of research. So when we raised money, we raised $2 million of seed funding back in 2014 just to get started. And we asked our investors, that if we take your check, it's on one condition, and that is you're not allowed to ask us for a business plan for a year. That was an unusual request, but they gave us the leash to really figure this thing out. So that was our opportunity to really characterize the science. And we tested 1,000 people in that first year. First, replicating other people's work, because we don't trust anybody. Just because it's in the peer-reviewed journal doesn't mean that it's actually facts. So we wanted to first replicate other people's other people's results, and then try to extend the frontier of what we know, and also ultimately, like, how can we build this into a product? So we tested 1,000 people in that first year, and the data really led us to a movement application. And when we started to thinking about accelerated movement-based learning, it naturally took us to sports. So it's not enough to get results in your lab. You have to be able to show that you can get results in a practical setting. So we started working with elite training facilities, universities, having access to college athletes, and we got results there. That gave us the confidence to continue working up the chain, working with Olympic and professional athletes, and we continue to get results. So that led us to the building of what I hold in my hand now. This is Halo Sport. And Halo Sport is just a fancy marketing term for a motor cortex-specific neurostimulator. So the motor cortex is in red, sits right above our ears. We borrowed from the headphone form factor and built in these special pieces, which we call primers, but between us in this room, they're effectively electrodes. Electrodes is kind of a scary word, so we like the word primer. So these guys are connected to an electronics board with a battery, and this whole unit talks to an app on your phone, and that's how you turn the stimulator on and off. But this is where the magic happens. These guys create an electric field that interact, in this case, with your motor cortex. So whether you're a violinist or Olympic powerlifter, what we want you to do is wear this for 20 minutes before your training. And our promise to you is that you're going to learn faster. You're going to develop that muscle memory faster. So I'm going to pass this around. Don't worry, it's turned off, so you're not going to accidentally shock yourself or anything. All right, so this is a picture, but you can actually hold it in a second. Just looking at some of the data. So this is looking at elite college and football players, dividing this group up into two. Half of them get real neurostimulation. The other half get fake neurostimulation. We call this a sham control group. So they have the stimulator turned on such that it feels like the real thing, but it actually doesn't work. So both groups think that they're getting the real thing, but only half of them are. So they don't know which group they're in. We don't know which group they're in. The coaches and trainers don't know which group they're in. So this is your so-called double-blinded, randomized, sham-controlled trial. We do a bunch of training and before and after testing. And in this case, we're really focused on leg strength. So we can test it with this Kaiser Air Squat, which measures the number of watts produced by your legs. And then we can also test it by testing how high you can jump. And across the board, the Halo group got better by about 12% versus 2% in the control group. So this was really exciting for us and led us to do more experiments. So we were now working with so this is not now, this is about a year and a half ago. We started working with the United States Olympic ski team. And here we're working on another vertical leap protocol, but this takes into account the way that you jump off a frictionless surface. So we're working with ski jumpers, and when they jump off the end of their ramp, they don't have the benefit of friction. They're jumping off of ice. So how do we mimic that? We put them on wood. On this contraption, the upper left, we call it slippery feet, but it's basically just wood on rollers. Trying to jump off that is really, really difficult. One of my employees tried, and he almost killed himself. It was almost my first workers' comp case. like a millimeter from being my first workers' comp case, which I wasn't looking forward to. So what we can do with these folks, and if you can just roll this for a second.
3, 2, 1, jump!
So this is an Olympic athlete, and even he has difficulty jumping off this thing, but he'll tell you that it feels like the real thing, which is great. When they give us this kind of feedback, we know we're on to like a pretty representative model of what they feel when they jump off the ice. So we put this whole contraption on what you can see below, kind of blurry, but that's a force plate. Think of your digital scale at home times 1,000. It's a $35,000 piece of equipment that measures force 1,000 times a second. And we can generate jump curves like this. So on the left is a bad jump. You see the wobbles? You can see a little wobble here, and a big wobble at the top. That's no good. This jump on the right is much better, and you can visually appreciate that. It's a much smoother curve. So we can measure the smoothness of the curve. We can also measure the area under the curve, which represents how much force was generated in a jump. And we can mash that up into one metric and measure the total quality of the jump. So what does that look like? So same kind of setup. The gray line is the control group that gets fake stimulation. The green line is the Halo group. And you could see after 10 training days, so this is about 3 weeks of calendar time, the Halo group gets better by about 31% versus 18% in the control group. So, it's this kind of data that gets us really excited. It's this kind of data that is proof to our customers and user base that we're onto something really big. Like when we think about athletes, like we have the strong position that practice is precious, and you need to take advantage of every rep, whether it's a game day rep or a practice rep. You need to take advantage of it. We are born with a finite number of lifetime reps, and every day we draw from that account. So what can we do to maximize every rep, every training rep? Because let's face it, training is not free. Right? With training, you induce training load, so you induce fatigue. You also expose the athlete to injury. So let's take advantage of every rep that we possibly can and get the most out of it. And the reason why we train all of these thankless hours is often not for the sake of our body. It's for the sake of our brain, to encourage our brain to remember what we just did. Like Steph is famous for practicing, I don't even know, like hundreds of thousands of shots to hone his craft to where he is. But I'll tell you, there's other athletes that practice even more than Steph, and they're not Steph. The reason Steph is because his learning curve is steeper. So we're just trying to we're trying to accelerate the rate at which people learn to help athletes get the most out of their genetic potential. So here's a quick video showcasing some of our athletes that use the technology.
Halo Sport is a headphone that's going to stimulate the motor cortex of the athlete's brain.
Being able to stimulate the motor cortex is key, because anytime the brain has a higher level of plasticity, not only will we retain the information quicker, but we're also going to engage more fibers, which results in greater force production and results in greater power output.
This is going to be something that's going to change the way we train athletes in the future.
All right, so we launched Halo Sport a couple of years ago, and we were only selling to select business clients, so the U.S. military, certain Olympic teams and professional teams. In November last year, we started selling to all comers. So now Halo Sport is available on our website. We're available on Amazon and a couple of other retailers. So it's really been an exciting time, for the company and also me personally to see this thing out there and helping people do amazing things. But there's a part of the business that I'm also really excited about, and this is a doctor in me, is that really sports is, we're just getting started with sports. What we can do with Halo Sport is we could also use it as a medical product. So this is longer lead and requires an FDA path, which requires clinical trials and this kind of thing. But this is my world. I'm not afraid of it. I'm actually quite comfortable like running these clinical trials to deliver the data package to the FDA to get approval. So to the same extent that we could perhaps help Steph shoot three-pointers better, again, this is all about movement-based training. Like, what if we could help a stroke victim walk again, right? Like, what if we could help a stroke victim with his or her physical therapy? This is a big public health problem in the United States because the acute care for stroke has gotten so good that people are surviving their strokes. 10 years ago, you would. Today, you do. And today, stroke is a chronic disease. 800,000 people have their first stroke in a given year in the United States alone. And half of these people have some sort of motor symptom. And their opportunity for improvement is very poor, especially in the chronic phase. So what can we do to accelerate the rate at which you learn from physical therapy? Like, let's use neurostimulation. We're also really proud of the work that we're doing with the military. So they were our first client. They continue to be our biggest client. So we started working with the Navy. Navy Special Operations first, and now we're working with Special Operations across all 4 branches of the military. And we're also the first recipient of an award from a new government entity called DIUX, which attempts to marry the military with new technology companies at a faster rate. And I guess in closing, we're just talking about movement, but let's think about neurostimulation more broadly. And let's just talk about human learning and how frustratingly slow it is. So our brains can do more. We have this latent potential in our brain that, on certain days of our life, we might be exposed to. And you might think you were in a flow state or something like that, but that's what you are capable of. Like, what if we can put you in that state more frequently in your life? Think about all the things that you would want in your life, but you don't even start because it takes too long to learn. Like, what if you wanted to learn Chinese? Think that would be a useful language? But you don't even start because it takes 10 years to learn to be barely good enough to have a dinner time conversation. It's too frustratingly slow. So imagine, what if you can unlock this potential so that you can learn faster? Like, what would you do today? And I will leave you with that. Thank you very much.
I think we have a few minutes for questions. Does anyone have a question for Daniel? Yeah.
So I noticed in some of the pictures of athletes that some were actively wearing a headset and others weren't. And then obviously you said that after 20 minutes of training, there's an hour latency. At what point does that cease to be beneficial? Or
Yeah, a good question. So we say use it for 20 minutes before your workout for a couple of reasons. One is that for many sports, the training thereof, it's really awkward to have headphones on your head. Like, at one end of the spectrum, it could be like a swimmer or a gymnast. Like, there's no way you could have headphones on your head. So the one-stop shop for instructions is just to use it for the 20 minutes before your workout. and take advantage of the afterglow, that 60 minutes of afterglow. But let's say you're a violinist and it's perfectly reasonable to have something on your head while you're training, then by all means, this state of hyperplasticity starts about 5 minutes into the stimulation session. So yeah, absolutely. Like if it's natural to you to have headphones on your head while you're working out, then like get after it, like right when you have it on. Any other questions? Yeah.
So right now it seems like you're focusing all your efforts on the motor cortex. You see future applications in the cortex or something big or something like that.
Yeah. So just maybe a little company secret. We're building our second product, and it's going to get after memory. It'll get after working memory. So it's a different part of your brain. It'll be a different product. It won't look like headphones anymore. But yeah, like we envision a portfolio of these different products out there. So targeting different brain regions for different applications. There's a, yeah. Yeah. All right, so we regulate that through the app. So we know our customers. If you tell an athlete that 20 minutes is good, they're secretly thinking to themselves that 40 minutes is twice as good. There's actually no long-term, I guess to the nth degree, like if you wore it constantly for days on end, something could happen, but it's really about diminishing returns. It's less of a safety thing. So we'll lock the athlete out after 20 minutes for 8 hours after that before they can use it again. And that's really an attempt for us to enforce just daily use, maximum daily use. Yeah. Sir? Oh boy. Right, so you probably looked up on our website. So they're $749. We plan on lowering the price point next year with another product that comes in at about half the retail price. Yeah. So we can take some of the output will be the same, so the quality of the neurostimulation will be identical to the premium version, but we could take away some of the polish so that we can reduce the cost.
All right. I think if you have more questions, Daniel will be here, so you can hang out and talk to him. So thanks, Daniel.
All right, thanks, Hale.